MongoDB database and MongoDB Atlas supports multiple authentication mechanisms for database authentication. These include SCRAM, the password authentication mechanism, certificate or X509 based authentication mechanism, AWS IAM, which can be used for both programmatic and employee or human user access, LDAPs, and Kerberos. Enterprises who have strict regulatory requirements typically use LDAPs, AWS IAM, and Kerberos for their employees or human user authentications, and they would typically use SCRAM, X509, or AWS IAM for the application or programmatic user authentication. So what are some of the challenges that organizations run when trying to use the existing mechanisms? LDAPs, if you as an organization are trying to use LDAP for your employees to authenticate with the database, then LDAP is an authentication mechanism that is really pre-cloud. In order to set up LDAP, you have to allow inbound network connectivity from your application to the database. It's not a cloud native option, as I mentioned. AWS IAM, if you have workloads running on AWS, then AWS IAM is a perfectly good option. But if you are running in other cloud providers, such as GCP or Azure, and you want to run MongoDB clusters in those providers, then AWS IAM is not really an option over there for your employees to authenticate with the database. So you're either left with LDAPs or with using a combination of SCRAM or X509 authentication mechanism. SCRAM and X509, organizations find them cumbersome to use for human users or employee access, because then they have to manage the entire identity lifecycle for these users. So the solution to all of these is identity federation, which is that your employees should be able to authenticate with the database, with their corporate identity credentials, and with the policies that your central IT team has enforced for your human users. So this is exactly what we have done. We have implemented OpenID Connect as a database authentication mechanism. With 7.0 release candidate, it is available as preview. So your employees or human users can then authenticate with the database in self-managed deployments, as well as in MongoDB Atlas using OpenID Connect. If you're using Azure Active Directory, Okta, or Ping, you can configure the appropriate MongoDB groups, and then OpenID groups, and then configure that authentication mechanism in Atlas, and then your users will then log in or authenticate with your corporate credentials. The benefits of using a mechanism like OpenID Connect are that now you can centralize the identity lifecycle for your human users who authenticate with a database. So no more worrying about that somebody leaves the organization. Now you have to worry about changing the credentials. Once those users have been decommissioned in your identity provider, they will no longer have access to the database. It also allows you to implement password policies such as MFA and password complexity policies. Of course, there is no credential sharing with the MongoDB deployments, and you can define session timeouts using OpenID Connect in the OpenID Connect based identity provider. This feature is available for free of charge. You can use it with the MongoDB Atlas deployments. And the reason we made this free of charge in Atlas is based on our secure by default philosophy. We want to make those security features available to our users for free as much as possible, because we want our users to use our platform in a secure and compliant way out of the box. No more worrying about configuration, no more worrying about paying for additional security features like OpenID Connect in MongoDB Atlas. Next, let me switch gears and talk about this new feature, user role. Let me build a context for this feature. This is again in the identity and access management theme. Say you are a hospital and you are storing two types of information in your in a JSON document. Now you got a medical diagnosis. You're storing medical diagnosis in a patient's JSON record, and you are also storing credit card information. The doctors or the healthcare providers within hospitals, within your organization, need to only see the medical diagnosis data, but not the credit card data. The billing managers, on the other hand, only need to see the credit card data, but not the medical diagnosis data. Today, how you can achieve this with MongoDB Atlas is that you will create two MongoDB database views, one for the billing managers, one for the healthcare providers. You will create one database role for each of those providers, and then you will create an appropriate aggregation pipeline for those views, and then those roles can only be used to query a certain view. The reason you have to create two views is because the database role information of those users is not available inside the aggregation pipeline that is set up in each single view. This is fine if you only have two views, but if you have a large number of views with overlapping logic, then the complexity of maintaining these views starts to grow. To address this problem, we have introduced this user role feature. What this feature does is that it allows the database role information of the user invoking the query on a particular view to be available inside the aggregation pipeline that is configured for that view. So in this code snippet, what you're seeing on the right, this is an incomplete code snippet. What you're seeing on the right is a pipeline that's basically saying that if somebody who is invoking this view with this aggregation pipeline, if they have the role providers, then they can see the medical diagnosis data. Otherwise, no one else can see the medical diagnosis data. Similar code snippet for the billing or credit card data is not shown, but it will be similar. So you define the pipeline, you define the roles. The user underscore roles.role variable is going to dynamically fetch the role and make it available and compare it with this logic. And so the advantage of this approach is that you are only creating a single view. You still have to create two different database roles, but you will assign those two database roles to this single view. And then the information is only available to the persona or to the roles that have the relevant roles. And effectively, you are implementing field-based access control using this user roles variable. Now, combining the feature I presented earlier, OpenID Connect, with this user role, so you can define your employee groups in your identity provider, OpenID Connect, and then you can map those groups to the appropriate database roles. And then when you create those views, you can assign those database roles to the views. And then your users, when they log in and authenticate with your identity provider credentials, will only be able to query data that is relevant for them. Moving on. Another theme I want to talk about is flexible X709 configuration. Some of you may be running MongoDB in your own data centers. So let me build some context for this. X709 is an authentication mechanism that is used in MongoDB for both intra-node authentication and for application to database authentication. MongoDB, as you know, is a distributed database. So there are nodes, at least in a replica set, in a 3-node replica set, there are 3 nodes deployed on different machines, and they need to authenticate among themselves, and they need to verify the identity of the other nodes. So in self-managed environments, what ends up happening is that typically there is only a single certificate authority available inside that organization. So the question comes up that how can MongoDB database differentiate between the authentications that are happening among the different nodes inside a deployment versus the application to database authentication if both certificates are signed by the same certificate authority. The solution that we had implemented a while back was to choose different values for the distinguished name attributes in an X79 certificate. Specifically, we had said that you should choose a different value for O, organization unit, O organization, OU organization unit, and DC domain component. So if they have different values for the server, for database, and different values for the client, then MongoDB can differentiate between the client to database connections and from node to node authentications. This works well, except that in certain organizations, they are not able to choose different values for these particular attributes, but they can add new attributes for the X79 certificate, or they can define custom X79 extensions. So that's exactly what we have done. We have allowed defining custom attributes for node-to-node authentication or intra-node authentication within MongoDB. So in this example, a custom attribute role equals database server XYZ is defined. When this is defined in the MongoDB configuration file, if the MongoDB nodes are presented with a certificate signed by the CA that has this attribute, the nodes know that this request is coming from a MongoDB database node as opposed to a database client. Similarly, we have allowed adding an X79 extension for node-to-node authentication. Moving on, this feature, the previous three features I talked about are available in 7.0. This feature is only available in Atlas. Prior to this feature, various Atlas organization roles, such as organization owner, organization member, were able to view the billing information. It was requested by our customers that they only want a subset of their users to view the billing information and not the organization members. So with this feature, what we have done is that we have introduced an organization billing viewer role in Atlas so that you can only users who are organization owner have the privileges of the organization billing viewer, or billing admin can view the billing information. The organization members no longer view the billing information. Let me switch gears from identity and access management and talk about the encryption features, starting with Queryable Encryption. Hopefully some of you got a chance to attend Ken and Cynthia's talk about Queryable Encryption. So I'll just give you a very quick overview of this feature. So what is Queryable Encryption? Queryable Encryption is an in-use encryption technology. It allows you to encrypt document field values before storing them in MongoDB database. The field names remain unencrypted. If you are storing same field values in different documents, those field values will be encrypted with a different ciphertext, right? So let's say I'm storing Salman, you'll think that it will be stored with, let's say, some gibberish XYZ. But with this technology, if you're storing Salman twice in different documents, Salman will be stored with different ciphertext. So in one document, it will be XYZ, and in another document, it may be ABC. The quote-unquote magic of this technology is that it allows running performant queries on encrypted data, on randomized encrypted data. So with 7.0, we released Queryable Encryption as preview last year, and it is expected to GA when 7.0 is available later this summer. In-use encryption technology is a journey that we have been on for some time. In 2019, we introduced client-side field-level encryption, which allows customers to encrypt data and run equality exact match queries on those data. Those fields were not you could encrypt fields with randomized encryption, but you cannot run performant queries with field-level encryption. In 2021, we acquired a company called Aroki. 2022, we formed the research group, and we released Queryable Encryption for the equality queries as preview, expected to GA later this summer. And then we have plans to release range and prefix-suffix queries after 7.0. Again, these are encrypted queries on randomized encrypted data. Since last year, we have made a number of enhancements to Queryable Encryption. These include security. We have done third-party cryptography review of Queryable Encryption. We had independent firm take a review the source code that has been written. We've also made a number of performance improvements. We have improved the developer experience, and we have created new encrypted indexes for Queryable Encryption for performant queries. In terms, if you're familiar with CSFLE or client-side field-level encryption, both are similar in many aspects. Both have the same developer interface. Both make it very easy to get started. The main difference between Queryable Encryption and client-side field-level encryption is that Queryable Encryption allows running performant queries on randomized encrypted data. You cannot do so with CSFLE. And it's only with Queryable Encryption that we'll be introducing range and prefix-suffix queries, again, encrypted queries on encrypted data. Next feature in the encryption space is the OpenSSL 3.0 support. OpenSSL 3.0 is the latest release of OpenSSL by OpenSSL.org. It has a number of security enhancements, including a standalone FIPS, or Federal Information Processing Standard Provider. FIPS is very important if you work with the US government. So starting with 7.0, it supports OpenSSL 3.0, and you can use it on RHEL 9, Amazon Linux 2023, as well as Ubuntu Linux 2020.04. And we have also backported the support of OpenSSL 3.0 to 6.0.6, which is the latest patch version of our prior major release. Moving on to the last topic in my presentation, backup compliance policy. This is an Atlas feature. This is not a database feature. So organizations that store financial data typically have very stringent requirements that the data that they are storing and the backups should be immutable. They don't want anybody in their organization to delete the backup, to change the backup schedules, to modify the backups, and so on and so forth. So based on the request on these organizations, specifically those who have FFIEC requirements or the Appendix J requirements, we introduced this feature by which, and once you enable this feature, it prevents anybody in your organization from disabling or modifying the backup policy or deleting the backup databases. So once you have enabled this feature, nobody in your Atlas organization, including the Atlas organization owner role, can delete the backups, disable the backups, or modify the backup policy schedule. In order to do so, you have to contact MongoDB support team. You are still able to configure the backup schedules, above the backup compliance policy level, but just not below it. This feature is available in Atlas for you to use today. With this, let me wrap up. So I gave you a quick whirlwind tour of the various security features that we have released in 7.0 release candidate, as well as MongoDB Atlas. They were covered across, I covered features across identity and access management, encryption, as well as backup compliance policy. Thank you very much for listening, and I'm happy to take any questions that you may have. Thank you. Yes. You may have to. Yes. Yeah, he's going to bring up the mic.
Thank you. So, okay, yeah, this is much better than me shouting my question. So thank you so much. Quick question about the queryable encryption. I hear that it is pretty much encrypted indexes.
Sorry, can you?
Is that applicable to the vector search that was just mentioned earlier today?
Yes, that's a great question. Queryable encryption is not available with vector search today.
Oh, okay. Thank you.
Sure.
So with the queryable encryptions, the encryption key is stored at the application level?
I can't hear you.
For the queryable encryptions, the encryption key, where the encryption key is stored? At the application level?
Yeah, that's a great question. The encryption keys for queryable encryption are stored, within your environment. So you can choose to store it, within your key management instances. It's with you, not with MongoDB. So that's the advantage of queryable encryption, that you encrypt the fields with the key under your control before you store the data in MongoDB.
Are you looking at having multiple encryption key per collection? What I mean by that is you could then start looking at the data segmentation by providing the different encryption keys to different set of the users.
Yes, so the question is, are we looking to allow multiple encryption keys for encrypting different data? We support some of that already, but I think it's a nuanced discussion. I'm happy to take that question offline with you.
Thank you.
What is the general availability date for 7.0?
Sorry, can you speak louder?
Sorry, what date does 7.0 become general availability?
It's expected to be generally available later this summer.
Hi, thank you very much for the talk. Question, OpenID available only on Atlas or on on-prem environments as well?
Yeah. So the question is OpenID Connect only available for database deployments in Atlas or also in self-managed? So OpenID Connect is available in the database with 7.0. So it is available for, in 7.0. And it is also available with 7.0 deployments in Atlas. Thank you very much for listening, and hope you have a great rest of the day. Thank you.